Okay, let's give you guys some practice. So sketch this graph in polar form. So ultimately you want to sketch it in polar form. So you want to sketch it in polar form here. But in order for you to sketch in polar form, you need to keep track of the radius. But here you've got r squared. So you've got to draw a graph of r squared, theta. And then from r squared, then draw another graph in terms of r. Once you have this graph here, then from here you can keep track of the radius. So you can then start to sketch the graph in polar form. Well, do whatever you want, sketch this graph in polar form. So press pause and have a go. Okay, so to do this, something you should realize is that when you put a negative version of the radius in there, the negative version, and then this whole thing here will simplify to this, which is exactly the same as the original. This simplifies to this. This is exactly the same as the original. So therefore we know the graph will be symmetrical along the origin, meaning if this here is 5, then this here is -5. So you've got a point here and a point here. Okay, well, it's symmetrical along the origin. So first thing we need to sketch a graph in terms of we need to sketch a graph in terms of r squared versus theta. So normally it will be 2 pi here, the sine graph, but you've got a 2 here, so it will have 2 cycles, 1, 2. So this is 1, 2. Okay, well, this thing here will be this. So now we need to square root this. So we need to square root this because we ultimately want a graph of r versus theta, so we can keep track of the radius. When you have when you're square rooting this thing here, well, this is negative here, so we can pretty much forget about this. We can pretty much forget about this because when you're square rooting, you can't really square root a negative number. So forget about this and forget about this. So here you've got a hump. When you square root a hump, don't forget this is 1. So this if you try and draw a graph of if you try and draw a graph of r 1 here, with square root of 1 will be 1. And then here you've got, well, r squared is 0 here. When you square root 0, it will still be here. Here, r squared will be 0, square root of 0, it will be here. So the point I'm trying to make here is that when you have a hump, and then you're trying to square root a hump, you're going to get a hump as well. So it will be this. It will be this. You're going to get one hump, but don't forget, when you square root, hang on, bear with me. Don't forget, when you square root this, you're going to get a positive version and a negative version. So this here is a positive version, and then this here is a negative version. Well, when you square root a hump, you're going to get another hump, this hump here, and then you're going to get the negative version. And then your r versus theta graph will look like this. Okay, if you get a graph plotter and plot sine 2 theta, it will look like the red curve. But when you square root this, which is this bit here, then it will give you the blue line. Don't forget the blue line is a positive version here. Don't forget you've got a negative version as well. Well, you can see the red line represents our sine 2 theta. When you square root the red line, you're going to get, well, the red line here, you've got a hump. When you square root a hump, you're going to get the blue line, which also happens to be a hump. So now that we've got the blue line, we can now sketch a graph. So hang on. So looking now we've got the blue line, we can sketch a graph. So when theta, so the radius at 0, so when theta is 0, the radius will be 0. So our point will be here. When it gets to pi over 4, when theta gets to pi over 4, so the pi over 4 will be here. Pi over 4 will be here. The radius will be 1. So the radius will be 1. Because it's symmetrical, because we know it's symmetrical about the origin, it will have the negative version. So this here is positive 1. And then because we know it's symmetrical along the origin, we know this here is -1. Or you can think of it like this. So don't forget our blue line is this one and this one here. So you're going to get 1 and you're going to get -1. So this here is 1 and this here is a radius of -1. So you're going to get this. So hang on, let's start again. When theta is 0, the point will have a radius. The point here will have a radius of 0. So that will be here. So when theta is 0, the radius will be 0. When theta is pi over 4, so when theta is pi over 4, hang on, when theta is pi over 4, the radius will be 1, and it's also -1. And then by the time it gets to pi over 2, the radius will be 0. So it's gonna go back to 0 here. So what's happening is, this. Notice that you've got to look at the blue line. Notice that the radius here increases. Looking at the blue line, you can see the steepness is very steep around here. Around here is very shallow, meaning that around here. So as you're moving around here, at first you're going to increase the radius will increase drastically, but then around this region the radius will increase and decrease slowly. So what that means is, well, don't forget, when theta is 0, the point would be here. When theta is pi over 4, the radius will be 1, and then by the time it gets to pi over 2, the radius will be 0. So it's doing this. But here's the thing. Around this region here, the radius increases drastically. Around here, it increases and decreases slowly. So the radius here will increase drastically. Around here, the radius will increase drastically, and then it will slow down, and then it will decrease drastically. The point I'm trying to make here is that around here, the radius will increase drastically. So your radius will do this. It will increase drastically, and then it will slow down, and then it will decrease drastically. So it will look something like that. And then don't forget, as you're moving around here, you're going to get the negative version. You're going to get the symmetry along the origin. So you're going to get something like that. And then around here, it just traces back on itself. So it's doing this here. But as you're moving around here, it's doing the exact same thing in this direction, because it's symmetrical. So as you're increasing in this direction, you're also increasing in this direction, and so on. So it really traces back on itself. This bit here traces back on itself. Well, get a graph plotter and plot the graph, and it will give you something like this. Okay.